How the internet works. You open your phone, type in a website, and press enter. And somehow, within seconds, videos, images, and text appear on your screen. It feels instant. Almost invisible. But behind that click is a global system of cables, computers, and rules working together at high speed. So today, we're going to calmly unpack how the internet actually works. No dramatic hacker scenes. No complicated jargon. Just the basic mechanics of how information travels around the world in a fraction of a second. Chapter 1. The internet is just a network of computers. At its core, the internet is not a cloud floating in the sky. It's a massive network of connected computers. Millions of them. Some are in data centers. Some are in offices. Some are in homes. When you connect to the internet, your device becomes part of that network. The key idea is connection. Computers link together using physical cables, wireless signals, and agreed upon communication rules. That's all the internet is. A network of networks. Chapter 2. Your internet service provider. When you go online, you're not directly connected to the entire world. You connect through an internet service provider, or ISP. That's the company you pay for internet access. Your ISP connects your home or phone to larger regional and global networks. Think of it like roads. Your driveway connects to a local street. That street connects to a highway. The highway connects to other cities. The internet works in a similar layered way. Local connections feed into bigger backbone networks that span countries and even oceans. Yes, the internet runs through undersea cables. A lot of them. Chapter 3. IP addresses. Every device has one. Every device connected to the internet has something called an IP address. An IP address is like a mailing address for your device. It tells other computers where to send information. When you request a website, your device sends a message that includes your IP address. The response knows exactly where to return. Without IP addresses, data wouldn't know where to go. It would be like sending a letter without writing the destination on the envelope. Chapter 4. Domain names and DNS. Now here's the part that makes things easier for humans. Instead of typing numerical IP addresses into your browser, you type domain names like example.com. Behind the scenes, something called the domain name system, or DNS, translates that name into the correct IP address. DNS is basically the internet's phone book. You type a name. It looks up the number. Your browser then uses that number to contact the correct server. All of this happens in milliseconds. You don't see it. But it's essential. Chapter 5. Servers and requests. When you visit a website, you're requesting information from a server. A server is simply a computer designed to store and deliver data. It holds website files, images, text, and videos. When you type a website address, your browser sends a request to the server that hosts that site. The server responds by sending the website data back to you. Your browser then assembles that data into the page you see. It feels like loading a single thing. But it's often dozens or even hundreds of separate files arriving and being assembled quickly. Chapter 6. Packets. Breaking data into pieces. Here's where things get interesting. Data does not travel across the internet as one giant chunk. It's broken into smaller pieces called packets. Each packet contains part of the data and information about where it should go. These packets may travel through different routes across the network. Some might go one way. Others might go another. When they reach your device, they're reassembled in the correct order. It's like sending a book by mailing individual pages separately and having them reorganized at the destination. Except much faster. Chapter 7: Routers and Paths. Routers are devices that direct traffic on the internet. They decide where packets go next. When a packet moves through the network, routers analyze its destination IP address and forward it along the most efficient path available. If one route is congested or down, packets can take another path. This flexibility is one reason the internet is resilient. There's rarely just one road between 2 points. There are many. Chapter 8: Speed and Latency. Two important ideas affect your online experience. Speed and latency. Speed refers to how much data can move per second. Latency refers to how long it takes data to travel from one point to another. Even if you have high speed, high latency can cause delays. This is especially noticeable in video calls or online gaming. Distance matters. The farther data has to travel, the longer it can take. Although we're talking milliseconds, those milliseconds matter in real-time communication. Chapter 9: Security and Encryption. When you see HTTPS in a web address, that means the data being sent is encrypted. Encryption scrambles information so that only the intended recipient can read it. Without encryption, data traveling across networks could be intercepted and read. Encryption ensures privacy and security for things like passwords and financial information. It's not invisible magic. It's mathematical protection applied to data before it travels. Outro. The internet feels abstract because we don't see it. But once you break it down, it's a system of connected machines following clear instructions. No mystery. Just engineering at a massive scale. If this explanation helped, subscribe for more calm, clear breakdowns of how everyday technology actually works. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.